Welcome to a video on comparing slopes over a set of ordered pairs compared to ratios over a set of ordered pairs. And we have already done this with slopes, and we're comparing these slopes from p sub 0 to p sub n. So that means we're spanning from 0 to 50 to 1, 338, and then 0 to 50 to 2, 462, and then 0 to 50 to 3 to 629, and so on. So we're going to be finding the slopes from this point 0 to 50 to all those consecutive points. 38 minus 250 over, now 0 to 1 is just 1 is the span there. The next one is going to be 462 minus 250 over 2, and then 629 minus 250 over 3, and so on. And continuing with those calculations all the way down, we get the following values from the first, second, third, fourth: 88, 106, 126.33, and so on. And you notice that those slopes are not very consistent. It's increasing quite a bit. So let's take a look at the ratios next. Okay, now to find the ratios, and usually, we abbreviate those values. The slope we usually call m. Sometimes we call it d. Ratios, that common ratio we typically call b. So to find those ratios, we usually take the p sub n, I'll just write the formula here, p sub n over p sub m, and we raise that to the 1 over an n minus m power. So like p sub 1 over p sub 0 would be 1 over 1 minus 0. So p sub 1 is 338, p sub 0 is 250. So instead of subtracting, we're dividing right here. 338 minus 250 versus now we're doing 338 over 250. Instead of dividing by 1, we get 1 to the 1 over 1 power, which is just 1 over 1, and we'll calculate that. That would be the first, we might call that b sub 1 or something, the first ratio. The next one, we're going to get the p sub n is going to be p sub 2, the 462, instead of 462 minus 250. Of course, this is 462 over 250, the ratio for that. And that takes two b's, like b times b is b squared. So we're going to have to take the 1/2 power for that. 1 over, this is the 2 minus 0. That's my exponent, 2 minus 0. And so we'll continue that all the way down as well, doing those calculations. And doing all those calculations from 1 to 5, we get the following values. We raise it to the 1/2, the 1/3, 1/4, and 1/5. And then here are our ratios. So those ratios being consistent implies that this is much better modeled by an exponential function. So as we come down below, it says you should take a look for consistencies in the slopes and consistencies in the ratios, and estimate a common ratio, which we'll take the overall average, the 1.35, this last one. So it says if the relation is better suited to an exponential model, which it is, it says use this form, p sub n equals p sub 0 times b to the n power. So we have found our p, b, and our p sub 0. Our b is equal to 1.35, and we know our p sub 0 is 250. So the formula would be p sub n is equal to 250, the starting value, times the common ratio, 1.35, raised to the n power, and that would be our exponential model. I hope you found this helpful.